By the end of this video, I'll expect you to understand where relationships come from on a data model and where you should actively look for them. The way we recommend you find them can be counterintuitive, so you will want to pay attention. A quick definition: seek means actively check in a specific place. When you play hide and seek, you're not waiting around for your playmates to reveal themselves. You're checking specific places. Are you in the coat closet? No. How about the laundry hamper? In data models, relationships have a way of hiding as well. So there comes a time where we need to seek them, and that's what this video will be covering. I'm going to start with some examples of what not to do. Suppose you have a model with 6 entities and no relationships. Where would you start to seek relationships? The users have the knowledge, but we can't just ask the users to start naming relationships. We need to ask specific questions to guide them. We could ask very specific questions like, is there some association between a gadget and a widget? This is standard language we use to seek a relationship. But is this an effective question to ask in this context? If you consider all these entities, there are so many similar questions we could ask here. These might all be good questions individually, but it would be exhausting and ineffective to ask them all. If you do the combination math, for 6 entities, you could choose 15 different pairs of entities to talk about. And for each pair of entities, we could actually find more than one relationship. Clearly, we need a smarter way to find relationships. Here's another problem. This is more subtle, and that makes it more dangerous. Suppose we're getting started with a data model for a car manufacturer, and so far we have only discovered 2 entities, car and wheel. There's really only one spot where we can seek a relationship here, so let's try it and see what happens. What's that language we use to seek a relationship? Try saying it out loud to yourself. We ask, is there some association between a car and a wheel? The users answer, yes, cars have wheels, and they might think you're a little dumb for asking. Note the word have. By saying cars have wheels, we've just determined this is a not-to-be relationship. That means cars and wheels definitely cannot be the same physical thing, at least not in this context. You draw in the line, make sure you add your question marks for checking for chicken foot on each side later. The very next step in the flow after discovering a not-to-be relationship is to seek a chicken foot. So you ask, can a car have several wheels? 2 users answer at the same time. Pedro says yes, and Laura says no. And so we have created another internet sensation where 2 people hear the same thing and perceive it 2 different ways. There's a famous audio clip that's gone viral online called Yanni Laurel, which is perceived differently by different people, even when 2 people are sitting right next to each other in the same room. This situation is similar to that, and now we have a problem. Our users disagree. This is a pretty simple example, and they would likely work this one out on their own. But if things were more complicated, Pedro and Laura might get in an extended argument about it. Because as modelers, we've made a mistake here. Suppose we failed to notice our mistake, and we interject to try asking them the converse question. Well, can a wheel have several cars? And now, again, the same 2 people disagree. How can this be? Before I answer, I'd like you to think about which person's answer seems right to you, Pedro or Laura. As data modelers, we know that when you get confused, you need to anchor your understanding with instances. So we ask Pedro and Laura to separately get out sheets of paper and write down examples of cars and wheels, as they understand it, to see if that helps. Here's what they produced. This explains why they disagreed. Pedro was thinking about concrete physical cars with mass. Laura was thinking about abstract car models. Which way did you think about it? This is something I call class instance confusion, and it's surprisingly common in software and computer science. One of our best tools to prevent this kind of confusion is precise naming. Typically when 2 ideas get confused, I like to suggest to the users that both concepts can be renamed so that the confusion doesn't happen again. The lesson here is that it's not time to seek and investigate specific relationships, and definitely not ask one or many questions until the entities have descriptors and identifiers. After that, the flow for relationships should go much more smoothly. Returning to this model, where would you start to seek relationships? It's a trick question. The answer is simple. Don't seek relationships yet. Seek descriptors. Recall that we seek descriptors one entity at a time. We ask questions like, what should we remember about each gadget? That gives the users the ability to speak up about relationships naturally. We ask that question, what should we remember about each gadget? The users tell us that each gadget is attached to a doohickey. That's great to know. We've just discovered a relationship. Most of the important relationships will be discovered this way. And remembering the car wheel example, we know to leave that alone for now and not go down the path of seeking chickenfoot yet. Now finally, I'll show the original topic of this video, which is actually seeking relationships. We can do this when everything we have so far is described and identified. Where do we look? Here's a model fragment for a photo sharing website with photographers and photos. We already have looked at each entity and sought descriptors and identifiers. And we also found that a photo has only one photographer, and a photographer has many photos. Are we done here? It may be counterintuitive, but the first and best place to seek a relationship is actually between two entities that already have a relationship. Entities have a natural tendency to be related in more than one way. We see photographer and photo are already related. So we ask, can a photographer be associated with a photo in some other way? This gets the users thinking more deeply. Then they answer, yes, a photographer can comment on someone else's photo. This introduces a second relationship, and we'll draw it in with the question marks. Because this is a second relationship between two entities, it requires labels. We'll apply as a label the exact language we heard from the users and read it out loud. A photographer can comment on a photo. Then we'll use our intuition to apply a label to the opposite link. Read that one out loud and make sure the users agree with it. A photo can be commented on by a photographer. What you see here is our first success at the seek relationship step. In the next two places, 2 and 3, we consider seeking a relationship between entities that are likely to have a to-be relationship. In number 2, we check between entities that have very similar names that you cannot distinguish. Here, job and task sound like about the same thing. In number 3, we check between entities that were created to replace a single entity that had an overloaded name. Here's a model fragment that previously had an entity called agribusiness, but the team realized that could mean two different things to two different people, and both concepts were important to the model, so it was replaced with these two entities, agribusiness company and agribusiness industry. After doing that, it would make sense to ask the users if there is some association between an agribusiness company and an agribusiness industry. The fourth and last place to seek a relationship is between two entities that are pivotal to the user's enterprise. This one's a little tricky. There's no exact recipe for what makes a pivotal entity, but essentially it means that the entity is discovered early, tends to be a common independent entity, and it tends to have a chicken feet out shape. If you had two different entities like this on the diagram, it would be worth checking if they should be related to each other. This is more advanced, it's intended to be used more sparingly, and I won't expect you to be able to apply this yet. I'm leaving this here as reference for modelers who may want to return to this video after getting more experience. Let's review. Here's a framework for finding relationships. The best way to find relationships is by simply seeking descriptors, as we did in an earlier video. The users will naturally tell us about relationships. For example, what should we remember about each camera? The users will likely tell us that about each camera we should remember the photos we took with it. That gives us a new relationship between camera and photo, and we didn't have to ask about photo. Once we've asked for descriptors on all of our entities, we continue seeking more relationships. But before doing so, make sure the entities you're asking about have accurate identifiers. This means going through the flow we discussed, with possibly introducing tiebreakers, considering over-identification, and so on. If we try to seek a relationship to or from an entity before we know its identifier, we run the risk of miscommunication, confusion, and you're going to have a bad time. Given that we've established identifiers for our entities, we now have a safe ground for seeking more relationships. But we still want to be smart about which ones we ask for. We want to consider seeking a relationship between two entities that already have a relationship, because it's common to find another, between entities that have names you cannot distinguish, like jobs and tasks, between entities that were created to replace a single entity that previously had an overloaded name, And finally, between entities that are pivotal to the user's enterprise, though this last one we should be careful about overusing. Now check your understanding.